Hey everybody, Vade here, and today we're going to be proving another one of the kind of common sense identities, and these are the co-function identities. So we're going to be doing it for sine, cosine, tangent, and their reciprocal. So that would be cosecant, secant, and cotangent. So let's start off here with just drawing a right triangle here. This kind of sucks, but it does. And so let's say it has two angles. This is, let's say, theta 1, and let's say that this is theta 2, and this is triangle ABC. So let's first choose, well, like sine of theta 1. Or no, let's first think about, let's see the first straightforward thing here is if we do theta 1 plus theta 2 plus then 90 degrees, let's work in radians here, plus pi halves radians equals to pi radian, right? So in other words, theta 1 plus theta 2 plus 90 degrees has to equal to 180 degrees, where in Euclidean geometry, sum of angles and triangles is 180 degrees. So if we want to express theta 1 in terms of theta 2, theta 1 would just be pi over 2 minus theta 2. And then theta 2 is just pi over 2 minus theta 1. So this will help us when deriving these co-function identities. So let's start off here. Let's use sine of theta 1 like I was doing before. Sine of theta 1 is opposite over hypotenuse, so b over c. I see here that also cosine of theta 2 is also b over c. But remember that theta 2 is just pi over 2 minus theta 1. So we can rewrite this as cosine of pi over 2 minus theta 1 is just b over c. So therefore, sine of theta 1 equals to cosine of pi over 2 minus theta 1. So we can then generalize this as sine of theta equals cosine of pi over 2 minus theta. Okay, let's do this now. Let's say cosine of theta 1. Cosine of theta 1 is just adjacent over hypotenuse, so that's a over c. But I see here that sine of theta 2, opposite over hypotenuse, is also a over c. Remember, theta 2 is just pi over 2 minus theta 1. So we can say that sine of pi over 2 minus theta 1 equals a over c. These both equal a over c. So we can say, therefore, cosine of theta 1 equals to sine of pi over 2 minus theta 1. Want to generalize this, we can say that cosine of theta equals to sine of pi over 2 minus theta. Okay. Now, let's think about tangent. So we can say that tangent of theta 1, right? That's opposite over adjacent. That's just b over a. We see here that, we see here that another thing that yields b over a here is adjacent over opposite. So we could say cotangent of, and again, I didn't memorize this proof or anything. I'm just going off of the picture here, trying to figure out relationships. So you're kind of going on this with me here. So cotangent of theta 2, that's just adjacent over opposite. So that's just also b over a. Now remember, theta 2 is just pi over 2 minus theta 1. So cotangent of pi over 2 minus theta 1 is also b over a. So we can say, therefore, tangent of theta 1 is just cotangent of pi over 2 minus theta 1. And if we want to rewrite this, we could also say cosine of pi over 2 minus theta 1 over sine of pi over 2 minus theta 1 using our quotient identity. Now, and we can also just generalize this here. We can say that, cotangent of pi over 2 minus theta and cosine of pi over 2 minus theta over sine of pi over 2 minus theta. And then this would be tangent of theta. And so now, let's see if we can figure out another relationship here. I see we can do like cosecant of, I don't know, theta 1. This is going to be, again, hypotenuse over opposite. And so then this will be C over B. And then just kind of thinking about what we had here, then, of course, secant of theta 2 also equals to C over B. And remember, theta 2 is just, and I'm going to just highlight these here. These are pretty important to just know. Theta 2 is just pi over 2 minus theta 1. So then secant of pi over 2 minus theta 1 is also C over B. So we can say that, therefore, cosecant of theta 1 is just equal to secant of pi over 2 minus theta 1, and we can generalize this to cosecant of theta equals secant of pi over 2 minus theta. Okay, let's see here. I'm just reversing what we did with these earlier proofs here. So I can say that if cosine, or if secant of theta 1 is just C over A, then sine of theta 2, cosecant of theta 2 is just also C over A. And remember, theta 2 is pi over 2 minus theta 1. So cosecant of pi over 2 minus theta 1 is also C over A. So you can say, therefore, secant of theta 1 equals to cosecant of pi over 2 minus theta 1. And we want to generalize this. We can say secant of theta equals cosecant of pi over 2 minus theta. And then finally, with cotangent, we could say cotangent. And I'm literally just reversing what I saw here. Cotangent of theta 1 equals A over B. Right, how I'm doing this is I got these initial three relationships for sine, cosine, tangent. I'm just flipping this. Like, if tangent of theta 1 equals B over A, then cotangent of theta 1 must equal to A over B. I'm using the reciprocal identities, right? So then, of course, if we see here, then tangent of theta 2, right, must also equal to A over B. So then, and remember, theta 2 is just pi over 2 minus theta 1. So tangent of pi over 2 minus theta 1 also equals A over B. And then we could say, therefore, cotangent of theta 1 equals to tangent of pi over 2 minus theta 1. We can generalize this to cotangent of theta equals to tangent of pi over 2 minus theta. So I can just write these all. So sine of theta equals to cosine of pi over 2 minus theta. Cosine of theta equals to sine of pi over 2 minus theta. And we can say tangent of theta equals to cotangent of pi over 2 minus theta. Cosecant of theta equals to secant of pi over 2 minus theta. Secant of theta equals to cosecant of pi over 2 minus theta. And cotangent of theta equals to tangent of pi over 2 minus theta. So really simple here. I just made up this proof on the spot here. I didn't look at any reference. I just said, okay, we have a right triangle ABC. We have two angles. Let's call them theta 1, theta 2. What are just some facts about this triangle, essentially, and how can we relate one angle to another? How can we relate theta 1 to theta 2? And so that's really it. It's just a common sense, like, kind of way of thinking about it. Again, a proof for this is not really needed. Just, if you know right triangles and sum of angles in a triangle in Euclidean geometry, just 180 degrees, pi radian. That should just help you out automatically. But, if you want something more concrete, here it is. So, yeah. Thanks for watching.